Hey, what's up, you amazing hackers? Welcome to Uncle Red's course on setting up a mobile Android testing lab. We'll also go over my methodology real quick. So, without further ado, let's get right into it, shall we? Now, today we're going to talk a little bit about why we need to do certificate pin bypassing, what Frida is, and some of the requirements that you're going to need to set up your mobile testing laboratory. We'll also set that up completely and install everything that we need, and then we'll set up the Frida server as well. After that, we can configure Burp Suite, and then we can use our script to inject our certificate pinning bypass. So that's quite a lot of steps, but I'll assure you guys it's not as hard as it seems. Now, first of all, some tips and tricks for you guys, because as a test automation engineer, I've had my struggles with test automation. And one of them is the certificate pinning, because we also did some security testing, and to do that properly, we had to do certificate pinning bypass. You guys might be wondering, what the heck is that? Well, we'll get some more into that later on, but basically comes down to the fact that we need to insert our burp certificate to intercept and decipher the HTTPS traffic. Just like any other HTTPS website, all these applications will also encrypt their traffic using certificates. Now, what you have to know is that we will use Android 7.1 or higher than that. But the devices need to be rooted before the device will accept those burp certificates. If you use Android 6 or lower, you don't have to root the device. That's important to know, because some applications, some targets, they might not run on Android 6 or lower. Usually they'll run on 7. If they don't, you can upgrade to 8, 9 and 10 and all that stuff. Sorry about that pop-up, by the way, guys. But if they do work on Android 6 or less and you don't want to root your device, this can be an option for you. Now, you can use Genymotion or Android Studio Virtual Device Manager for this. We'll be using Genymotion for this, but it's important to know you can just as easily use the Android Studio Virtual Device Manager. And sometimes the Frida script that we use, it won't work. That's because some programs use a little bit more sophisticated custom certificate pinning, and then we'll need to do some different stuff, but that's outside of the scope of this course. We'll mostly focus on standard applications like Twitter, for example. That's where this course will work on. Now, it's really important that you guys can use objections as well. That's a framework built on top of Frida. But again, we won't be going into this very much in this course. Now, you might be wondering, Uncle Red, why do we need the certificate pinning bypass that you keep talking about? And it's really simple actually. As I told you guys before, mobile apps, they encrypt their traffic using HTTPS, just as websites would do. They use the same certificates that websites would do, and we can insert our burp certificate into Android to capture those requests. But developers might protect against this kind of behavior to make it harder for us hackers to actually break our target. They can really easily do this by implementing what's called certificate pinning. This is when your application checks to make sure that only its own certificate is used to encrypt the traffic. Now, our solution to that is we can basically overwrite that piece of code that checks which certificate is being used. And we'll use Frida for that. There's also a link to learn a little bit more about Frida, but basically Frida is like a grease monkey for native apps. What it does is it dynamically injects pieces of code, and those will let you overwrite already existing code. It can do that in Windows, macOS, Linux, iOS, Android, QNX. So Frida is freaking amazing, guys. It gives you some simple tools that are also built on top of the Frida API, which we won't be using that much of, but they can be used as is, or you can change them completely because they're open source and you can go in and make the necessary changes. So, as for the requirements, you might be wondering, okay, so I know what Frida is, I know what certificate pinning bypass is, what do I need, Uncle Red? Well, if you want to get started, you'll need to connect a real device via USB, or you need to download Genymotion and create an emulator. For the recommended emulator, I would recommend you guys create a Google Pixel XL device, and the least amount of Android version I would recommend is 7.1 Plus for the reasons that I mentioned before. Some applications, they might not support older Android versions. And then we need to install those Frida packages for Python. We can either do that using the Python module pip, or we can directly install it using pip. It'll depend a little bit on how the setup of your Python is on your computer. After that, we also need the platform tools, and we need the Android device bridge, debugger bridge. I noted down device bridge, but it's the debugger bridge, of course. And that's one of the platform tools that's provided for us. So we'll download those entire platform tools. We'll extract all of them to our local drive, just like we see in here. If we go back to the documents real quick, and we'll go to the mobile course. Here we have the platform tools, and in here we have ADB. Now, you also need the following script to bypass certificate pinning. This is a universal script. Some apps will use more custom certificate pinning and will need more custom scripts for those apps, but again, that's a little bit outside of the scope of this course. Now, to start, first of all, start your emulator and then go to settings and the developer options, and in there you can tap to enable USB debugging. That will be important because if that's not enabled, we can't go and actually interact with the device from our computer. We'll need to do that for sure, especially if we want to work with ADB. And then we also want the path where we extracted our ADB to into our path variables. This is so that when we type ADB, we know that the command prompt will actually scan all the paths that we have in our path variable, and then it will look in those paths if it can find an executable with the name that we've typed. So to do that on Windows, we can just copy the location of the ADB path. For example, C users, downloads, platform tools. And then we can press the Windows R key and we can enter sysdm.cpl and whatever pops up. And then we can click on the Advanced tab. Now in the system variable window, you can find a path variable, which you can click to edit. And you can click New, which will add a new entry for a path, and you just enter the path that you entered in here. So simple as that. Then you've added ADB to your path variables. You should always restart your command prompt as well. That's pretty important, otherwise Windows won't load those new path variables. On Linux, it's pretty similar, only we have to change a file there. I still have Windows on here, but of course that's not Windows, that's Linux. That's also changed in the final version of this presentation. We need to change to our home directories, and then we need to open the bash source file, bash rc file and we need to add a following line, and we need to replace that directory here, which is not the JDK directory, but the local ADB there, of course. Again, will also be changed. You need to replace this with the directory of your ADB, which will be the platform tools directory again. And then you need to export that path variable. So that's what this command is going to do. We'll save that file, and then we'll use the source command to force Linux to reload that bash rc file. Normally, every time you log in, that also happens automatically. But since we don't want to log out and log in every time that we add something to our path variable, we can force that using the source command. For Frida, okay, so now we have our mobile emulator running. We actually need to set up a Frida server on that mobile device. And to do that, we need to get the Arch version of the device by running this command. And this will run that ADB tool, which is why we had to add it to our path variables. and it will run the shell command and it will get the property, this specific one. That will show us which version of Android we are working with, and we need to download and extract, really important guys, extract the server version of Frida from this web page here. And you need to make sure it's the server version, and you need to make sure that you extract it as well. Then we need to push Frida server to the device and give it permissions to execute, of course. So for Windows, that would be adb push and then your Windows path to the Frida server. And this is the path on the device, which would be data local temp, just a temp folder. And on Linux, we can do the same, adb push and then the adb path to the Frida server, only the Linux path this time. And again, push it to the data local temp. And then we want to change mode to 777 so we can execute this. And we want to do this to the Frida server. Now your file might not be named Frida server, so be mindful that you actually use the correct file name in here. Now to set up Burp, really easy, just open Burp Suite, go to your proxy tab and then open these options tabs here. And then you have a button, import export CA certificate. If you click that, you can export your certificate in a dir format, which is really cool. Make sure you do that in this case because we need that certificate. And then we need to push that certificate onto our device. We need that later for Frida, so it's very important that this step goes right. And we do this using the adb push command, and we will push our ca-cert.dir to the data local temp folder again. And we'll rename it to the cert extension. This is important because we'll need that cert extension later on. Make sure you have that correct. Now the script to bypass that certificate pinning also needs to be on the device. So that script that we downloaded earlier, we can push that onto the device using the adb push command again. And in here we either enter our Windows or our Linux path to the fridascript.js, and we want to again push it to the data local temp on the emulator device or on our real device, of course, that's also possible. And then we want to check and run that Frida server on that device. Now if we execute this command, adb shell data local temp Frida server and the ampersand command, this will execute our Frida server in the background. And then of course we can list all the processes running on the device using the Frida ps-u command. If this command gives you trouble, something went wrong when you pip installed your dependencies. So take a look at that again, make sure those are correct, and then if those are correct, then maybe you need to troubleshoot a little bit further, but those should be popping up then. Now we need to locate our package from that list, and we can easily just do that by looking at the name of the application we are looking for example Twitter, and with that package name we can then start up our script to inject the bypass for our certificate pinning. Now to do this, real simple again, we need to execute the Frida command -u and then the -f, and here you fill in your package name, the one that we got from the previous step, and then we add the -l parameter, and here we add the fridascript.js file on our computer. We add a few other options, and this needs to be in a new rule because this would be an example, and this is fixed in the new version of the PowerPoint as well, of course. So it would be like frida-u-f com.twitter.android-l d fridascript.js -- no pause. And then if we execute this, we have bypassed our certificate pinning, guys. If we now browse through our application, we should no longer be seeing those annoying warnings that our certificate pinning is not happening correctly, or that we have some SSL errors in Burp. Because let's face it, guys, that's really annoying, and we just want to test our application. Well, now you know how. If you still get errors, that might be because the fridascript.js is not right because it's again a very broad default script, but your target might have their own custom implementation of the certificate pinning in place. And it's really important that we do have our own script for that. And there are some other tools that can help us there. Now onto the methodology. So first of all, it's really cool that you guys want to test mobile applications, but what's really important as well is that you pick the right platform and the right target for you. Because if you pick the wrong target, you might think that the type of vulnerability you are looking for doesn't even exist in the wild. But guys, guess what? These dependencies are highly these vulnerabilities, I mean, of course, are highly dependent on your target as well, and on what technology they have underlying, but also what type of business logic they have built into them. So it's very important to pick your platform properly, and there are 3 major players in my opinion. Those are just the major ones. Of course, there are also some smaller players, some private platforms like Synack to which you have to apply, and then there's programs who have their own security.txt on the website. We can do some Google dorking to find those. There's also firebounty.com, which collects all of these security.txt files into one big searchable database. So with that in mind, I'll describe the big platforms first. For me, my favorite would be Integrity. I really love Integrity. It's kind of become my home. This happened because when you actually report something on Integrity and it turns out to be an invalid vulnerability, you don't get negative points. As of the recording of this video, which is the 28th of January 2021, sorry, it might be changed in the future, so make sure you check that. It also happens to be that in Integrity, there is a lot of the types of targets that I like to hunt on. There's a lot less competition than some other big bounty platforms, and there's also a really good community support for us. Because if you do report a few good vulnerabilities, you might get invited to their Slack channel where you can talk to the people at Integrity directly. That will make things a lot easier if you have some questions, of course. Now, all of these points are based on my opinion, guys. Opinions can change and alter over time, so it's really important that you do make up your own mind and think a little bit. You need to pick a program that's right for you, and I encourage you to check that out yourself. Now, these bullet points that I've made are useful, but you should always do your own research, of course. You don't have to pick one of these major platforms. That's also very important to know. You can choose a regional or smaller platform, which might have a lot less competition, but then also they will have a lot less programs to pick from. Now, Integrity, they have a little bit of a smaller selection as compared to Bugcrowd or HackerOne, but that's not necessarily a terrible thing in my opinion. It's about the quality of the targets that matter, not about the quantity. That being said, I in no way am convinced that HackerOne or Bugcrowd contain negative targets, like these targets which have very small scopes or which don't have a lot to hack on. I am in no way convinced that the bigger bug bounty platforms have a lot more of those. Let that be clear. So what's also going to be a disadvantage for some of you for Integrity is that their programs are going to be in Dutch or some other European language. But that can also be an advantage if you just install a translator plugin. It's a barrier for English-speaking people, and that's really an advantage for everybody as a hunter, because if barriers are raised, other hackers drop off, which gives us more chance for actually finding those vulnerabilities without them being a duplicate. Now, there could also be a little bit more public programs in my opinion on Integrity, but there's at least a very good selection to start off with and to choose from. HackerOne, I don't have a lot of experience with that platform, but they host CTFs that gives you private invites when you find a flag, really freaking cool. They have a huge selection of programs, a huge selection. They have great triagers as well, and they'll actually help you out, and they'll write comments on your reports which will guide you in a direction to help you along on your journeys. Really important for me that they don't just say, okay, report invalid. If you create an invalid report, you will get negative karma. However, get too much of that and you will have to prove yourself in a trial period. This means that you can't submit for a number of days, and if you do, you have a number of trial reports to prove yourself. Since it's also the biggest bug bounty platform, there might be quite a lot of competition, but also a lot of targets to distribute your competition upon. As for bug route, they have a lot of positive items as well. They have a huge selection again, but those are the guys I am least familiar with, so I don't have a lot to say about them. As for picking a program, for me again, it's like picking a shoe. Make sure that you pick a program that fits, because you don't want to walk on blisters all week long. Believe me, you don't. And I really want to always test applications that have a lot of functionality in them, preferably even different levels of privileges, where I can create my own users even. Those are usually business to business applications, and I'll update these examples as well with some more that have mobile applications in them. Some general tips: try not to take very broad scope targets. Recon is going to do you no good in mobile pen testing. It might do you a little bit good, but it's not going to be the end all be all. Take a main application that has a lot of functionality in there and make sure that you focus on the things that we will talk about in a few moments. Now, as for vulnerability or paid programs, I usually recommend vulnerability disclosure programs where they give you points, no payment, because when you do, there will be less hackers, because there's no pay again. Less hackers is always good for us. They might be a lot less hardened due to their nature as well, since they don't have to pay you money when you find a vulnerability. And if you get some points, you will get private invites, and you will get points if you report vulnerabilities that are actually good. So fine-tune your strategy on vulnerability disclosure programs, wait until the paid programs follow, and then hack like your life depends on it on them. As for my strategy, my mobile strategy is very similar to my web strategy. I basically don't really participate in static code analysis though. I really do participate mostly in dynamic hacking. That means basically running my application and seeing what requests are being sent to the server. I focus on the APIs and not really on the mobile part of it, because in my opinion, mobile operating systems are made to be very secure. And that being said, I don't believe that they are infallible or unhackable, because nothing is. I just believe that they are more secure than your average web application, because that usually is accessed by Windows, and Windows has nowhere nearly of a strict model as mobile applications for their security. Now, when you first start attacking, try cross-site scripting. Don't think, oh, this is a web app, this is an application for my mobile phone. This is not web, I can't do cross-site scripting in here. Some applications run on WebView, which also runs JavaScript, so that means cross-site scripting, guys. Really important. I give you guys an example of an attack vector, but make sure that you build your own. Insert that into every field that's possible, and since you're working in an emulator, you should be able to copy paste as well, which makes things a lot easier. After registering, fully explore the website like any normal user would. This is very important, and make a mind map of the functionality. I usually use Xmind, and I also write it down on paper, because writing things down on paper seems to burn a hole in my memory and I remember things a lot better. While doing all this, I have Burp Suite Proxy open in the background, of course. I manually explore my application quite deeply, and I make sure to insert cross-site scripting attacks whenever possible. Make sure that you have your scope set up properly, because then your sitemap will be populated while you use the application. We need that for later. There's also a manual, I'll read it if there is one, That's very important again, because as bug bounty hunters we need as much information about our enemy as we can get. We're kind of at war, and the more information we have, the better for us. Things like Swagger documentation, if they are available on the API, I'll go through that again. Even though we're talking about mobile hacking here, I'm attacking an API, that's what's most important. Again, I'll also make sure to insert cross-site scripting attacks wherever possible, because if a part of my application is vulnerable, then I want to know as soon as possible. The whole process of exploring my target can easily take a couple of days. And the cool thing about mobile is that I can actually explore my application on my actual mobile phone and take it with me and test a little bit manually on the go as well. That's a really cool part about mobile bug bounties. Now again, I use Xmind to make my notes. One thing I also wanted to tell you guys, when you start out you're going to see Burp make a whole lot of strange requests and say a lot of false positives about your target. Don't jump on that thinking you can report it immediately. Make sure that you actually write a proof of concept, or don't even bother reporting it at all. If you can't prove the impact, there is none. That's a rule in bug bounties. Well, it's not a rule per se, but it's something I think we bug bounty hunters should always strive for. And then after I'm done manually exploring my website, I'll explore the requests in Burp Suite as well. If you click the target tab and the sitemap, you can have a filter in here. Just click this bar on the top, and then you can show your parameterized requests. A lot of other cool filter options as well, but we'll focus on the parameterized requests right now. This is because parameterized requests, they are the interesting ones for me as a bug bounty hunter. I don't care about static websites, because those are not interactable. I want to interact with my website and actually hack. I don't care about static stuff. Now, as an example I can give you is sort of like a Facebook website. We all know Facebook. It has several features like creating a post, and we can click like on that post, and we can also add comments and stuff like that. Now let's say when you create a post, we send this content field to API/create post, and this creates a post for us. Now if we want to like it, we send a post request to API like with the post ID in it, and we get a like counter back which says 1 like has been added. Then if we send the unlike request, we send a request to /API/unlike with the same post ID, and 1 like is subtracted. Now a smart hunter might automatically think, let's mess a little bit with the order of those requests, and let's just keep sending the like request over and over and over again without ever sending the unlike request. And that might give you some of the basic logic vulnerabilities that we are looking for. Now, what parameters do I test for what vulnerabilities, you might be wondering. If it seems to interact with the logic of a web application, then I'll try to test that very, very thoroughly for business logic. Now, this is why it's so important that you know the application very well. You need to know its functionality before you can know when functionality is not behaving as expected. Any parameters that seem vulnerable to any parameters that contain a URL, and that resolve that URL, I might try SSRF on, but I won't go too deep into it because SSRF is hardly ever fully exploitable, at least for me. There are other people who are cracked at SSRF, but I'm a complete noob at it. Any parameter that appears to grab some files, I'll maybe try local or remote file inclusion on, but again that's going to be a lot more edge case scenario, and CSRF parameters, if they are present, I'll test those as well. I'll try to save my account settings, personal settings, any settings that I can find, and I'll look for hidden parameters, both in the request itself and also in the response, because if I have a parameter in my response that is not in my request, I'll copy it over and I'll try to change it anyway. You never know if the server might react to our parameter and update the value. As for the automated testing that I do, I usually test for IDORs and broken access control, and I create 2 accounts of the same account. Then I also create 2 users in that account, and it tests for IDORs. So it's just a user and a different user, and I test for IDORs between them. I will also test between the accounts. So if I'm a company like Google, for example, I'll register as Google and I'll create accounts for my employees. And I'll also register as Yahoo and I'll create accounts for those employees. I'll try IDORs in between the 2 organizations. That's what this first line is. Then I'll also create the 2 users for Google and I'll try IDORs between those 2 Google users. And then I'll also try for broken access control if I have an administrator at Google and a normal user. So that's a lot of different ways that you can test for broken access control. I usually use authorize for this or auto repeater, but I prefer authorize because it's a little bit more specialized. I also want you to know that it's really vital that you test all of the privilege levels. If you can create your own, you should do it. And this is again why I really like testing these business to business applications. It's usually them where you can create your own accounts. Now the same rules apply as for your normal bug bounty targets, guys. It's very important that you register with your Bugcrowd Ninja, WeAreHacker1 or Integrity.me email address, because you want to not have your target come onto a blacklist for spamming emails. As we are testing, we are generating a lot of email traffic, and that might cause our targets to end up on a blacklist for emails. We really don't want that. As we're testing those, some applications might call it a role, others might call it a group. As long as you can set different levels of privileges and play around with them a little bit, you'll be fine. That's what it's all about. Playing around with those different levels of privileges and seeing if you can find any broken access control. So you'll log in as your low privileged user, take their authorization headers, copy them over to authorize, and then you'll log in as your high privileged user, such as your administrator, and you'll start clicking around with authorize on. This will repeat every request that you make as your high privileged user. It will repeat that as a low privileged user, and it'll then compare the responses of those 2 requests. If the responses match completely, which means status code and content, then authorize will say bypassed, but you have to be careful because some functions don't contain an identifier such as user ID. If they don't contain that, then IDOR is already impossible. And those functions, they might also not be vulnerable to broken access control because they might be something that every user should be able to do. When it comes to different levels of privilege, I talk about people who can execute functions such as an administrator and people who can't, such as a normal user. After all of this is said and done, I'll try injecting all of these parameters with some command injection techniques, and I'll try to identify some other endpoints as well by using paraminer or by doing some parameter brute forcing, but I prefer to stay away from the brute forcing. As a general tip, I want you to know your application very well, because if you see a vulnerability, I want you to be able to recognize that and also be able to exploit it further. Should you take this methodology to heart? No, I want you to base your methodology on what I just told you. There's quite a lot of things that you can do, there's quite a lot of things that you can expand on as well, but it's basically just API testing from this point. So, my dear friend, my amazing hacker, thank you very, very much for choosing Uncle Red to teach you how to do some mobile bug bounties. I genuinely appreciate it from the bottom of my heart. Thank you so much. And if you would like some help installing this live, I have also included a voucher code for a 1-hour coaching session with Uncle Red. And I'll guide you through this whole process. If you have any questions, I'll also guide you through those. I hope you have a great hunt, and I hope that the next time I hear from you, you will be the next $1 million hacker. Bye bye, amazing hacker. See you soon.